Okay, on page 20, you have the following picture and a formula, which is the surface area of a right pyramid with a regular polygon base. Whew. Now, if you look at your formula sheet, this formula is not on there. So you have two options. Either you could memorize this formula, which I don't think you'd want to, or you could figure out if I wanted to find the surface area of this shape. Can you see that if I cut along it and fold it open, that the sides are all triangles? In fact, if I cut it open, I could draw the hexagon. Hexagon is a six-sided shape. And off of each of these, ooh, that's kind of pretty. Does that make sense that if you cut it open and laid it flat, that you would have the base, which is a hexagon, and 6 equal triangles? So to find the surface area of a right pyramid, you would have to find the area of the base. And then if you found the area of one triangle, does it make sense that you could just multiply that by 6? Now, the formula that's here does that same idea, but they change it a little bit, because how do you find the area of a triangle? You do base times height divided by 2. And in this formula, it has the perimeter of the base of the whole thing. Can you see that the perimeter of this, which is going all the way around, is just adding up all 6 bases? Does it make sense that this is, the perimeter is 6 times the base of one triangle? So we can maybe see why the two formulas are the same. You could either do 6 equal triangles, which is probably what I'd recommend because this formula is not on there, or we could use this formula. Okay? Now, in the next question, it does say use the formula, but we have to be careful here because it's asking for the lateral area. And the lateral area is different than the surface area. How is it different? Doesn't include the bottom. So if my surface area formula was 1/2 height times perimeter plus area of base, then my lateral area doesn't need the area of the base. So my surface area, 1/2 height, or sorry, not height, it's S, right? Thank you. S is the slant height. So basically, can you see, given the information here, if you looked at one of the triangles of the side of this pyramid, would you agree that one of the triangles looks like this? It has a base of 5 and a slant height of 12, so the height of that triangle would be 12? Good. Now, if we use the formula is really nice and straightforward. We'd have 1/2. We know that the slant height is 12. We know that the perimeter is going to be 6 sides, 5 on each side, 30. Multiplying this out, we get 180. Do we have any units? Yes. We're doing area, so and area would be centimeters squared. Now, you're telling me that you'll probably not remember a formula like this if it's not on your formula sheet. So if you had to find the lateral area of a pyramid with a hexagon as a base, my suggestion is find the area of one triangle. Can you see that the area of this triangle would be base? That's not my base. Would be the base times the height divided by 2. And the area of this one triangle then would be 30 centimeters squared. How many triangles are there? 6. So then does it make sense that you could figure out the lateral area by doing 6 times 30? And notice we get the same answer, 180 centimeters squared. So if this question came up on a test, I think you would use the blue. You would figure out the area of one triangle. Notice that you have 6 of those triangles all the way around the edge and get the area that way. Because you won't have this surface area or lateral area formula. Okay? And the formulas, the ideas are basically the same. One is just using the perimeter to do the 6 times 5. And the other one multiplies the 6 at the end. So we get the same answer. Just a preview of what we're going to be doing tomorrow. We start with a pyramid that has a square. Then we have a pyramid that has 6 sides. And then more sides. And as you keep adding sides to the polygon at the bottom, more and more and more of them, can you see eventually it morphs into a perfect cone? So the reason the formula that we just looked at is kind of cool is because the lateral area, which is just, right, the triangles around the side, the formula for that was 1/2 times the slant height times the perimeter of the base. And as we morph it into a circle, can you see that the perimeter of the base becomes the circumference? And so the lateral area just becomes 1/2 times the slant height times the circumference, which, very cool, the 2's cancel out, and so you just get pi times r times s for just this blue shaded part. If you wanted the surface area of a cone, and look on your formula sheets, surface area of a cone, it's on there. Can you see that it has the pi rs? And then it adds pi r squared. Pi r squared is the area of the circle at the bottom. So what we'll be doing tomorrow is we'll be looking at this formula for the surface area of a right cone. And that formula is on your formula sheet, but it's kind of nice to see we just were able to discover where this part came from.